something once and only once inside of your view controller, odds are it belongs in whatever initialization method the app delegate is calling. And that's this guy here. So I copied and pasted its signature. I call the parent class to make sure everything gets initialized properly higher up in the hierarchy. And now I'm doing this. So I realized after trial and error that I actually need to keep track of how, whether or not there's an alert view already in progress. Because in the first version of this program, if you held down on Tommy's face and held there too long, you would keep getting alert view after alert view. And you'd have to hit OK like 10 times if you held on ever so slightly too long on his face. So this is my way of just locking the UI alert view so that only one message is actually sent when you touch down on his face. So that was just in response to that. So I'm setting no, because by default there's no alert view obviously in progress. Now I prepare my array of Tommies. So I've got apparently a property that's of type NSArray. I'm allocating my array. I'm initializing it with this comma separated list of NS strings. Tommy1, Tommy2, Tommy3, comma nil. Common mistake when you're declaring an NS array statically in this way, it has to end with nil, even though you would think the method could infer that for you. You do need to nil terminate it yourself. And then self.index equals 0. So what are these properties? Well, if I scroll up here, I have some private properties that I've declared. Private just because no one else needs to know these exist. They don't need to go in the header file. So I'm trying to practice that principle now. So what do I have? This is just a Boolean, alert in progress. And notice that because it's a primitive, it's just a sign. Weak and strong do not apply. This is not a pointer. A sign just means make copies of this thing when you pass it around. Non-atomic has to do with threading. Read write does what it says. What else do I have? Well, I have this array of Tommies, or rather a pointer to an array. This is strong, just as for my dictionary words before, because I definitely want these Tommies all kept around in memory, even if the application is backgrounded. I just don't want to have to reload this array again and again and again. And it's reasonably small, so that's reasonable to keep around in memory. Index. Well, I've got an array of 3 things, and as you swipe from left to right or right to left, I just need to keep track of which Tommy am I showing on the screen. So this is going to be a number from 0, 1, or 2 in this case. And then lastly, there's this IB outlet. It is weak, even though it's a pointer, because I'll let the nib worry about keeping this thing around in memory. And now the UI image view, we haven't used this ourselves yet, but just as you can drag and drop buttons and text fields and tables in, so can you drag in placeholders for images called image views, and I simply drag this onto my interface. I made it fill the screen, and I did change a couple things. I did use things like aspect fill so that it would maintain Tommy's proportions, but it would still zoom in to fill the available space, and crop as needed, but I could align him in all sorts of different ways, some of which would, if scale to fill, would make him look very squished or fat depending on the dimensions of the photo. So this just worked out well, aspect fill. And this is important because I want to be able to touch this image, which is not a typical expectation for an image. I need to make sure that user interaction is actually enabled. Otherwise, no messages will be triggered when I touch on this JPEG on the glass. So now, what do I have inside of this? Well, if I right click, notice that this image view is indeed connected via an outlet to the file's owner, namely the view controller. So I clicked and dragged to make that connection over to the file's owner. So let's see how I can now respond to some gestures as we begin to make a fancier interface here. So I've got down here my synthesized properties. I've got some alert view stuff. Let's focus on one of the easier ones first. So this thing here. So it turns out that because I have, let's see, actually let's start slightly elsewhere. Let's start down here. So we looked at init with nib name, and that's what kickstarts the object's initialization. But I then want to do some GUI related stuff only when the GUI has been loaded into memory. And that does not happen when init, or init with nib name is called. That happens when view did load informs me as much. So you don't want to start touching the GUI in your init method because it might not literally have been read in from the nib. The RAM might not have been allocated. It's too soon at that point. In the world of JavaScript, you think back on the method that's often called DOM ready or some variant thereof. Same idea. If you try executing JavaScript code too soon, the whole HTML DOM might not have been constructed as a tree in memory, so your code's just not going to do anything. Same deal here with the UI. So view did load needs to do a few things here. So on this first line, I'm going to first load whatever the default image is. So here I have self.imageview.image. So imageview is the object. .image is actually a property that should be set equal to a JPEG or PNG or supported file format. And then here I have a UI image class, I'm calling the convenience method named image named, and I'm specifying call self.tommies, which is an array, give me the object at index self.index. So by default, that was initialized to 0. So I'm saying give me Tommy at index 0, which is tommy1.jpg. Then I'm passing tommy1.jpg as a string to the message image named. So what I'm getting back now is a UI image object that's been initialized with tommy1.jpg. And I'm assigning that to the image view property called image, and that's what makes the first Tommy appear. It's as relatively simple as that. Now what happens next? I now need to inform the entire UI mechanism to start listening for these things called gestures. And so with this next line of code, I'm going to listen for that long press, holding his face slightly awkwardly too long. So I'm going to declare a pointer called long press gesture, and it's of type UI long press gesture recognizer. So the keyword here is recognizer. This is a framework that Apple provides that allows you to recognize interesting UI interactions. I'm allocating one of these recognizers, and I'm initializing it with a target. So what does this mean? This is introducing another paradigm in iOS. So self is me, the view controller. So you can think of this as assigning it a delegate pointer. So inform me when some gesture is recognized, in this case, the long push. Well, which method should you actually pass, which message should you pass to me when Tommy's face is touched too long? Well, the method called handle long press. Now, the one thing we haven't seen before is @selector. So I mentioned, I think, a couple weeks ago that selector is effectively synonymous with message name or method name. And it kind of is. But really here, what I'm doing is handle long press colon is being passed to @selector. @selector is going to return a special representation of that message that's designed to be passed around. So you can think of the net effect here as being effectively a function pointer. Or in JavaScript, the name of a function. In JavaScript, functions are actual first-class objects, which means you can pass them around by their name. The @selector syntax is allowing us to do that here as well. So that means call this message on this object myself when a long press is recognized. And the next two chunks of code are very similar, but they're for right swiping and left swiping, respectively, which mean when the user drags in sort of a typical way on a mobile device. So what happens then when I do touch on his face and a long press gesture is recognized? Well, let's scroll up to that handler. And up here we have handle long press. First, I do this. If it's not the case that an alert is already in progress, and this I realized by trial and error. I was triggering so many damn alert views, I put in this protection. So if there's none already in progress, go ahead and specify, yes, there is one in progress. Then go ahead and allocate an alert view just as usual. Notice that I've done this here. Hey, stop that, fine, and so forth. And then I show it. But I'm also using a delegate in another sense here, telling the alert view, I am your delegate, inform me when it's done. Because what do I probably want to do as soon as the user dismisses this alert view? Exactly. I want the opportunity to invert the value of alert view in progress, which I'm going to have to do in whatever that message handler is, and that's this one here. And we've seen this before. I just need an opportunity to know to do something when the user has touched that button. So for time's sake, let me wave my hands at the swiping, but it's pretty much the same idea, except you do need to distinguish between left and right, which I'm actually doing generically with a method I called handle swipe. And I'm using a constant here and a switch to determine if it was left-right or right-left. And then here's some sort of CS50 style code where I am incrementing the index, but making sure to wrap back around to 0 with the modulo operator. But that's just some old school logic there. All right, so that's how we implement that. We can do one more where you can actually do affine transformations of graphics in a very similar way, but that can create this kind of effect here. So this is our transformations example. If I go ahead and compile this, it again features a familiar face. But in this case, if I take my two fingers or simulate them with the Option key and click like this, I can now zoom out and I can zoom in fairly infinitely if I keep doing it. It's not the highest quality picture, but you can see where this is going, right? Think Google Maps, but with Tommy here. So how do we go about implementing something like this? Well, it's actually pretty much the same principle, except now we're actually using some C code. And this will be a good transition to Pong, which you'll find reveals that a lot of the graphics capabilities in iOS are still implemented in C, partly for performance, partly for historical reasons. So if you missed C, here we go again. So this is my M file, viewcontroller.m. Let's ignore this. CG point refers to core graphics point, and we'll come back to that. But I've got some private properties here, just as before. Notice I've got a pointer to an image view, so I can have a Tommy image loaded there by default. This time I have a floating point value for scale, which is going to represent 1.0, 2.0, 0.5, whatever the scale factor is after pinching. And then I've got another, actually I didn't need this. I should delete this. I don't need an array of Tommies anymore because I only included one image in this file. So I'll clean that up after. I've synthesized some variables here, but now notice I have two methods I've implemented. Handle panning, which means dragging Tommy around, left, right, up, and down, and then handle pinching, which means using two fingers to resize the image on the screen. So here's my initialization method this time. So I'm going to prepare Tommy by remembering by default he's at 1.0, and by default the translation of him. He's going to show up in this rectangle by default. And a translation, recall, is some shifting left and right, x-axis, y-axis. So by default, the translation for this image is just going to be nothing. It's going to be at the topmost origin of the screen. And just to paint a picture, the way graphics work in iOS, this is just a quick sense, incidentally, of the sort of gestures you can recognize. So the slide will be online. The coordinate system looks like this. In an iPhone, the 0, 0 is in the top left-hand corner. So keep that in mind as we play around with numbers. And if I go back now to the code here, I've now initialized underscore translation. What is that? Well, let me scroll back up here, and aha. Underscore translation. So this is a CG point. If not sure what this is, you can option click, and you'll see that this is a C struct. And CG point is a structure containing a CG float, which is core graphics floating point number. It's essentially just a float, x and y. So this refers to an x comma y pixel coordinate location on the screen. But it's not quite pixel location, because those of you who are Apple fans might know that Apple has released higher resolution versions of things, the new iPad, the iPhone 4 with the Retina display. We'll come back to that guy maybe. So there's actually a genericization of the notion of a coordinate system in iOS. You actually interact with an iPhone device today in terms of points, where a point might be 1 pixel, or it might be 4 pixels, the sort of doubling of a pixel. So this way you can express locations on the screen independent of whether the user has an iPhone 3 or an iPhone 4, an old iPad, a new iPad. So you'll see the terminology of points in there that could be one-to-one mapped to pixels, but might also be much smaller. Case in point, the new iPad's resolution is twice that, and the new iPhone's resolution is twice the iPhone's resolution. And that would just be a nightmare, because now you would have 4 views, but now you can actually just have 2. Because for many applications, the Retina display is sort of immaterial if you're using some standard UI widgets or photo that's going to just look better by nature of it being on a better screen. So I've made this translation I variable a private instance variable. Now, this is not a property for reasons that I'll wave my hands at for now, but realize for today's purposes, a cautionary tale, be careful trying to represent structs with properties. Things tend to break, and Xcode will often yell at you. And the quick teaser for why is that if you've got a property called foo, and you want to access it, you would access it via this mechanism here. Self.foo, if that's a property called foo. Now suppose that foo is a struct, like CG point, with an x and y field. Well, back in C, how do you access the members of a struct? Dot notation. So you might say foo.x. So this looks completely reasonable, and in fact this would work okay. But suppose that you want to do something like this. Self.foo.x plus 1. Suppose you want to move the thing over 1 pixel. So now this doesn't actually work. Why? Because you have to go back to the basics of what a property actually is. Self.foo is just syntactic sugar for what? Passing a message, exactly, called foo to self. Now, a struct is effectively a primitive, right? It's not itself a pointer. A struct is a struct. And think back to C. Whenever you call a function and it returns some value, if it's not a pointer, it's a value, and values are passed by copy. So what are you going to get back when this message returns a value? You're going to get back a CG point, but a copy of a CG point. So that when you then say .x, that's fine. You can access the x coordinate. But if you then try to assign it to be some other value, you're wasting your time. Why? Because you're just updating the copy. And so understanding the underlying details of implementation here are super important, because on the one hand, Xcode will yell at you. And so if worst case, you'll just scratch your head as to why you can't do this in iOS programming. But this is actually the reason why, because you're actually calling a function and it's returning a value, but it's returning a copy of a value because of the way the stack frame works. And so you can't actually mutate that X value purposefully. It's just going to be changing a